Welcome. My name is Michelle Ufford, and I am your humble narrator for today's talk. I also lead a team at Netflix focused on data engineering, innovation, and centralized solutions. And I want to share with you some of the really cool things we're doing around analytics, and also how we ensure that the analytics that we're delivering can be trusted. I also want you guys to understand that this stuff is really, really hard, and I'm trying to give you some ideas on ways that you can deal with this in your own environment. Netflix was born on a cold, stormy night back in 1997. But seriously, it's 20 years old, which most people don't realize. And as of Q2 2017, we have 100 million members worldwide. We are on track to spend $6 billion on content this year. And you guys watch a lot of that content. In fact, you watch 125 million hours every single day. These are not peak numbers. On January 8th of this year, you guys actually watched 250 million hours in a single day. It's impressive. As of Q2 2016, we are in 130 countries worldwide. And we are on over, I think, around 4,000 different devices. Now, there's a reason why I'm telling you this. We have 100 million members watching 125 million hours of content every day in 130 countries on 4,000 different devices. We have a lot of data. We write 700 billion events to our streaming ingestion pipeline every single day. This is average. We peak at well over 1 trillion. This data is processed and landed in our data warehouse, which is built entirely using open source big data technologies. We're currently sitting at around 60 petabytes and growing at a rate of 300 terabytes a day. And this data is actively used across the company. I'll give you some specific examples later. But on average, we do about 5 petabytes of reads. Now, what I'm trying to demonstrate to you in this talk is that we can do this and we can use these principles at scale, but you don't need this type of environment to still get value out of it. It's just showing you that it does work at scale. So now for the fun stuff, the unfortunate events. And events is actually a play on words here. When I say events, what I'm really talking about is all of the interactions you take across the service. So this could be authenticating into an app. It could be the content that you receive as to like what we recommend for you to watch. It could be when you click on content or you pause it or you stop it, or when you click on that next thing to watch. All of those are considered events for us. This data is written into our ingestion pipeline, which is backed by Kafka, and it's landed in a raw ingestion layer inside of our data warehouse. So just for those who are curious, this is all 100% based in the cloud. Everything you see on this, it's all using Amazon's AWS. But you can think of this S3 as really just a data warehouse. So we have a raw layer. We use a variety of big data processing technologies, most notably Spark right now, to process that data, transform it, and we land it into our data warehouse. And then we can also aggregate and denormalize and summarize that data and put it into a reporting layer. A subset of this data is moved over to a variety of fast access storage, where that data is made available for our data visualization tools. Tableau is the most widely used visualization tool at Netflix. But we also have a variety of other use cases, so we have other visualization tools that we support. And then this data is also available to be queried and interacted with using a variety of other tools. Every person in the company has access to our reports and to our data. But this is what happens when everything works well. This is what it looks like. Let's talk about when things go wrong, when you have bad data. But really, I don't like the term bad because it implies intent. And the data is not trying to ruin your Monday. It doesn't want to create problems in your reports. So I like to think of it as unfortunate data. This is a visualization. It's actually, I think, one of the coolest visualizations I've ever seen. It's a tool called Visceral. And it shows all of the traffic that is coming into our service. And every single of those small dots is an API. And those large dots represent various regions in our AWS. So if you look here, you might notice one of these circles is red. And that means that there's a problem with that API. What that means is that we're receiving, for the most part, data, but we might not be receiving all data. We might not be receiving one type of event. So in this example, let's say that we can receive the events when you click play on new content, and when you get to the end and you click to play next episode, we don't see that, right? So let's just use that as a hypothetical. So now we have our bad data, our unfortunate data that is coming in, and let's say, just for example purposes, that this is only affecting our tablet devices. Maybe it's the latest release of the Android SDK caused some sort of compatibility issue, and now we don't see that one type of event. It could be that the event doesn't come through at all. It could be that the event comes through, but it's malformed. It could be that it's an empty payload. The point is that we are somehow missing the data that we're expecting. And it doesn't stop there. It makes its way through our entire system, goes into our ingestion pipeline. It gets landed over into S3. It ultimately makes its way to the data warehouse. It's going to be copied over to our fast storage. And if you're doing extracts, it's going to live there too. And ultimately, this data is going to be in front of our users. And the problem here is that you guys are the face of the problem. Even though you had nothing to do with it, you created the report, and the user is interacting with the report. It is generally not going to be your fault. Sometimes it's your fault, but most of the time, what I've observed is that issues with reports are quote unquote upstream. What does that mean? Every single icon and every single arrow on this diagram is a point of failure, and not just one or two possible things that could go wrong. A dozen or more different things could go wrong. And this is a high-level view. If we drill down, you would see even more points of failure. So it's realistic to expect that things will go wrong. Compounding this problem for us is that, according to Sandvine, Netflix accounts for 35% of all peak traffic in North America. So I've described the problem. We have some bad data. We have some unfortunate data. That is not the issue itself, right? I mean, what does it really matter if I've got unfortunate data sitting in a table somewhere? The problem is when you are using that data to make decisions, right? That's the impact. And it is my personal belief that there is no other company in the world who is more data-driven than Netflix. There are other companies who are as data-driven, and they're not as big, and there are bigger companies, and they're not as data-driven. If I'm mistaken, please see me afterwards. I would love to hear. But when you're really a data-driven company, that means that you are actively using and looking at that data. You're relying upon it. So how do we ensure they still have confidence? Well, first, let's look at all of the different roles we have from Netflix and why I think we're so data-driven. We start with our data engineers, and from my perspective, this is just a software engineer who really specializes in data. They understand distributed systems. They are processing that 700 billion events and making it consumable for the rest of the company. We also have our analytics engineers who will usually pick up where that data engineer left off. They might be doing some aggregations or creating some summary tables. They'll be creating some visualizations, and they might even do some ad hoc analysis. So we consider them sort of full stack within this data space. And then we have people that specialize in just data visualization. They are really, really good at making the data make sense to people. I'm curious though, how many of you would consider yourself like an analytics engineer? You have to create tables as well as the reports? Wow, that's actually more than I thought. It's a pretty good portion of the room. How many of you only do visualization? Show of hands. Okay. So more people actually have to create the tables than they do just the visualizations. Interesting. So those are the people that I consider these data producers, or they're creating these data objects for the rest of the company to consume. Then we move into our data consumers, and this would be our business analysts, which are probably very similar to your business analyst. They have really deep vertical expertise, and they are producing analysis like, what is the subscriber forecast for EMEA? We also have research scientists and quantitative analysts in our science and algorithms groups, and they are focused on answering really big, hard questions. We have our data scientists and machine learning scientists, and they are creating models to help us predict behaviors or make better decisions. And these would be our consumers. So these people are affected by the bad data, but there's really no impact yet. It's not until we get to this top layer that we really start to see impact. It starts with our executives. They are looking at that data to make decisions about the company's strategy. Many companies say they're data-driven, but what that really means is that I've got an idea and I just need the data to prove it. Oh, that doesn't look good. Go look over here instead, until they can find the data that proves their points. You can go off in the direction they want. Being data-driven means that you look at the data first and then you make decisions. So if we provide them with bad data, bad insights, they could make a really bad decision for the company. Our product managers, we have these across every verticals, but one example would be our content team. They are asking the question, what should we spend that $6 billion on? What titles should we license? What titles should we create? And they do that by relying upon predictive models built by our data scientists, saying, here's what we expect the audience to be for a title. And based upon that, we can back into a number that we're willing to pay. This is actually a really good model for this because it allows us to support niche audiences with small film titles, but also spend a lot of money on things like the Marvel and Disney partnerships where we know it's going to have broad appeal. We have our algorithm engineers who are trying to decide what is the right content to show you on the site. We have between 60 and 90 seconds for you to find content before you leave. And I know it feels like longer than 60 or 90 seconds when you're clicking next, next, next. But that's about how long we have before you go and spend your free time doing something else. And then we have our software engineers who are trying to just constantly experiment with things. They look at the data and they roll it out to everybody if it makes sense. And this could be everything from the user experience that you actually see to things that you don't see. Like, what is the optimal compression for our video encoding so that we can lower the amount of bandwidth that you have to spend while also preventing you from having like a really bad video experience. So these are the impact is really at that top level. So how do we design for these unfortunate events? I mean, we have the data, we've got lots of data, we've got lots of people who want to look at it, a lot of people who are depending upon it. You know, and I think that you have two options here. The first option is you can say, we're going to prevent anything from going wrong. We're going to check for everything, and we're just going to lock it down. And when something gets deployed, we're going to make sure that that thing is airtight. And that works. That sounds good in principle, but the reality is that usually these issues don't occur when you deploy something. Usually, everything looks great, and then 6 months later, there's a problem, right? So it's a lot, in my perspective, a lot better instead to detect issues and respond to them than it is to try to prevent them. And when it comes to detecting data quality, now I'm going to get a little bit more technical here, please bear with me. I think that all this stuff that was really relevant for you guys, and I think that there's some really good takeaways for you, so there's a reason why I'm showing you this. So we're going to drill down into this data storage layer. And we're going to look at this concept of a table, right? And so in Hadoop, how many of you actually work with Hadoop at all? How many of you work with only like you work with like an enterprise data warehouse, but it's on something else like Teradata? Okay. So in Teradata, a table is both a logical and a physical construct. You cannot separate the two. In Hadoop, you can. We have the data sitting somewhere on storage, and we have this concept of a table, which is really just a pointer to that. And we can choose to point to the data, we can choose to not to. One thing, though, that we've built is a tool called Metacat. And whenever we write that data, and whenever we do that pointing, we are creating another logical object. We're creating a partition object. And this partition object has statistics about the data that was just written. We can look at things like the row counts, and we can look at the number of nulls in that file and say, okay, we're going to use this information to see if there's a problem. We can also drill down a little bit deeper into the field level, and we can use this to say like some really explicit checks. We can say, well, I'm checking for the max value of this metric, and the max value is 0. And that doesn't make sense unless it's some sort of negative value for this field, but chances are this is either a brand new field or there's a problem. And so we can check for these things. You don't have to do things the way that I'm describing, but the concept I think is pretty transferable. Having statistics about the data that you write enable a lot more powerful things. Okay, so now that we have the statistics, I mean, we can use them in isolation and say, oh, we got a 0, that's a problem. But typically, the issues are a little bit more difficult to find than just that. And so what we can do is take that data and chart, for example, row counts over time. And you can see that we've got peaks and valleys here. And this is really denoting that there's some difference in behavior based upon the day of week. And so if we use a standard normal distribution, we can look for something that falls outside of like a 90% confidence interval. And if it does, we can be pretty confident that maybe there's not a problem, but we definitely want someone to go look to see if there's a problem. And so when we compare this for the same day of week over week for 30 periods, we start to see that we have some outliers. We have some things that might be problems. We can also see that the data that we wrote most recently looks really suspect, because I wrote 10 billion rows, and typically I write between 80 and 100 billion rows, right? So chances are there's a problem with this particular run of the CTL. So we can detect the issues, but that doesn't really prevent the problem of the impact. The perennial question, can I trust this report? Can I trust this data? I have no idea, looking at this, if there's a data quality issue. And what's really problematic, and what is really the issue for you guys, is when people look at these reports, they trust the reports, and then afterwards we tell them, that data is actually wrong. We're going to back it out, we're going to fix it for you. There was no indication to them looking at this report that they couldn't trust it. But now, the next time they look at this report, guess what? It's going to be there in the back of their mind. Is this data good? Can I trust it? So what we've done is build a process that checks for these before the data becomes visible. And all of the bad, unfortunate stuff can still happen. We still have the data coming in. It's still landing in our ingestion layer. But before we write it out to our data warehouse, we're checking for those standard deviations. And when we find exceptions, we fail the ETL. We don't go any further in the process. We also check before we get to our reporting layer. Same thing. What this means is that your user is not going to see their data, right? They're going to come to the report, and it looks like this. Your user, your business user, is going to see there's missing data, and now they're going to know there was a quality issue. And we don't want them to know that, right? Wrong. We want them to know there was a problem, because it's not your fault there was a problem. There's so many things that could go wrong. But simply by showing them this explicitly, that we have no data, they retain confidence. They know they're not making decisions based on bad data. And your business should not be making major decisions on a single day's worth of data, right? Where it becomes really problematic is when you're doing trends and percent changes, and those things, even bad data, can really have a big impact. So one thing that you do have to do to make this work is you have to surface the information so that users can really see, when was the data last loaded, when did we last validate it through? So there's two things: not showing them bad data and providing visibility into the current state. This is a view of our big data portal. It's an internal tool that we've developed. I think there's other third-party tools out there that might do similar things. We're also planning to add visibility to the actual failures and alerts so that business users can see those. So now we've detected the issue, we've prevented there from being any negative impact, but we still have to fix the problem, right? They still want the data at the end of the day. There's two components to fixing the problem quickly. The first one is, as I just mentioned, visibility. But this time, visibility for the people who need to understand what the problem is and they need to fix it. So one of the things that we're doing is surfacing this information. The question might be, why did my job suddenly spike in runtime, right? Why is this taking so long? And you can look here and you can easily see, oh, it's because you received a lot more data. And then this becomes a question. Well, was that because somebody deployed something upstream and now it's duplicating everything? I mean, it gives you a starting point to understand what are the problems. We also directly display what the failure message, or the failures, and then give you a link to go see the failure messages themselves, so that when users are trying to troubleshoot it, again, we're just trying to make it easier and faster for them to get there. And we are exposing the relationships between data sets. So this is the lineage data. How do these things relate? What things are waiting on me to fix this? And who do I need to notify that there's a problem? All right, now I'm going to cover this real quick. This is about scheduling and pulling versus pushing. Not something that you guys here would implement, but something that you should be having conversations with your infrastructure teams about. Traditionally, we use a schedule-based system where we say, okay, at 6 o'clock, my job's going to run, and I'm going to take that 700 billion events, and I'm going to create this really clean, detailed table. And then at 7 o'clock, I'm going to have another job run, and it's going to aggregate that data. At 8 o'clock, I'm going to have another process that runs, and it's going to denormalize it to get it ready for my report. I'm going to copy it over to my fast access layer at 8:30, and by 9 o'clock, my report should be ready. In a push-based system, you might still have some scheduling component to it. You might say, well, I want everything to start at 6 a.m. But the difference is that once this job is done, it notifies the aggregate job that it's ready to run because there's new data, which notifies the denormalized job that it's ready to run, which notifies or just executes the extract over to your fast access layer, and your report becomes available to everybody by maybe 7:42. You could see the benefits here in being able to get to data, getting the data out faster to your users. This is not why you guys care about this. This is probably why your business users might care about it. Why you guys care about it is because things don't always work perfectly. In fact, they usually don't. And when that happens, you're going to have to reflow and fix things. So this is actual table that we have. We have one table that populates 6 tables, which populates 38 tables, which populates 586. This is a pretty run-of-the-mill table for us. I have one table that by the 3rd level of dependency has 2,000 table dependencies. So how do we fix the data when the data has started off in one place and has been propagated to all of these other places? In a pull system, you rerun your job. And my detailed data, my aggregate, my denormalized view, all of these views get updated, and my report is good. But the other 582 tables are kind of left hanging. And you could notify them if you have visibility to who these people are that are consuming your data, but they still have to go take action. And what's going to happen is you're going to tell them, hey, we had this data quality issue and we reflowed, And it's really important that you rerun your job, and they're going to think, okay, yeah, but I deprecated that, and yeah, I might have forgot to turn off my ETL, and they have no idea that somebody else has started to rely upon that data for their report, right? Happens all the time. People don't feel particularly incentivized to go rerun and clean up things unless they know what the impact is. In a push system, we fix the one table, it notifies the next tables that there's new data, which notifies those tables that there's new data, and everything gets fixed downstream. This is a perfect world. It's very idealistic. This is like a very pure push type system. What you should be having discussions with your internal infrastructure team is that you should not need to know that there is an upstream issue. You should just be able to rely upon the fact that when there is a problem, your jobs will be executed for you so that you can rely upon that data. Nobody should have to go do that manually. It doesn't scale. Part 4. So we've gone through this, and we talked about some of the different ways that unfortunate data would impact us. But that's not the reality for us. The reality is that our users do have confidence in the data we produce. That doesn't mean there's not quality issues, but overall, generally speaking, they have confidence that what we produce and what we provide to them is good. And because of that, we're able to do some really cool things. Our executives actually looked at the data for how content was being used and the efficiency of it, and they made a decision based upon the data to start investing in originals. And over the next few years, we went from, I think it was a handful of hours in 2012 to about 1,000 hours of content in 2017. We've ramped this up very quickly. And we have set a goal of, by 2020, 50% of our content will be original content. 50% of that $6 billion that we're spending will be on new content that we create. But this was a strategy decision that was informed by the data that we had. We also have our product managers who are looking at the data, and they're making some pretty good selections with what content we should be purchasing on the service. We've had some pretty good wins, and they're going to continue to use the data to decide what is the next best thing for us to buy. We have our software engineers who have built out constantly evolving user interfaces, user experience for us. And this doesn't happen all at once. This isn't like a monolithic project where they just roll out these big changes. Instead, they are testing these. They're making small changes, they're testing them incrementally, and they're making the decision to roll it out. We have about like 100 different tests going on right this moment to see what is the best thing that we should do. And so you can see what we looked like in 2017, or 2016. Here's what we looked like in 2017. So you can imagine for a moment the amount of complexity and different systems that are involved in making something like that happen. And before we really make that investment, we go and test it. Is our theory correct? One thing that I think is really interesting is that we find oftentimes we can predict what people will like if those people are exactly like us. And usually people are not exactly like us. And so instead, we just throw it out there whenever we have ideas, we test them, and then we respond to the results. And then we have our algorithm engineers. These are the people who are responsible for just putting the intelligence in our system and making it fast and seamless. And so the most well-known case is our recommendation systems. I could talk about it, but I actually think this video is a little bit more interesting. Now, we did not create the video, but we provided the data behind the video. 80% of people watch content through recommendations. 80%. We did not start off there at that number. It was only through constant iteration, looking at the data and getting or responding to the things that had the positive results that we got to this place. Okay, so we'll start wrapping up. The key takeaways. Obviously, I don't expect you guys to go back and do this in your environment, but I think that there are some key principles that really make sense for a lot of people outside of just what we're doing here at Netflix. The first one is that expecting failure is more efficient than trying to prevent it. And this is true for your data teams, but this is also true for you as data visualization people. How can you expect and respond to failures and to issues with the data and with your reports rather than trying to prevent them? So shift your mindset and say, I know it's going to happen. What are we going to do when it happens? Stale data. I have never heard someone tell me, I would have rather had the incomplete data faster than I had the stale, accurate data. I'm sure there are cases out there where that is true, but it is almost never the case. People don't make decisions based upon 1 hour or 1 day's worth of data. They might want to know what's happening. They might say, I just launched something and I really want to know how it's performing. I mean, that's a natural human trait, that curiosity. But it is not impactful, right? And so ask yourself, would they rather see data faster and have it be wrong, or would they rather know that when they do finally see the data, maybe a few minutes later, maybe an hour later, that it's right? And this is actually, I know this is really hard. It's easy to tell you guys this. I know that you have to go back to your business users and tell them this. I realize that. But if you explain it to them in this way, usually they can begin to understand. And then the last thing, this is really validation for you guys. I've had a lot of people ask me, how do you guys do this? And we have all these problems. And the reality is that we have those problems too. This stuff is really, really hard. It's hard to get right. It's hard to do well. It's hard for us. And I think we do it pretty well. I think there's a lot of things we can do better though. So just know that you're not alone. It's not you. It's not your environment. Take this slide back to your boss and show them, like, this stuff is really, really hard to do right. Okay. Please, when you are done, complete the session survey. And that's my talk. Anybody have questions? And if you have questions and you're not able to stay right now, feel free to find me afterwards. I'm happy to answer them. Yes.
Hi, thanks for the very insightful talk. I had one question. I was curious when you showed the dependencies diagram. Let's say you have a mainstream table that has a couple of hundred or let's say 1,000 tables feeding downstream dependencies. And if you had to make a change, I'm sure like no table design is constant. So for the upcoming changes, how do you manage to ensure that you are still flexible for those changes and also are fulfilling these downstream dependencies for the historical data also?
So the question is, how do you identify and ensure that there are no issues in your downstream dependencies when you have thousands of tables?
No, it's rather like if you had to make a change, how do you make a quick enough change and also make sure that you have the data historically for a major upstream table?
Are you wanting the change applied to your downstream tables?
Yeah.
Oh, okay. Good question. So how do you quickly evolve schema, probably, and apply that downstream? The first thing is you have to have lineage data. Without lineage data, you can't really get anywhere. So the first step is always to make sure you have lineage data. The second thing is around automation and your ability to understand the data and understand the schema. So if you can understand schema evolution and changes there, then you can start to apply them programmatically at any point where you can automate. So automation of ingestion and the export of data would be an optimal place. Beyond that, you could start to, it becomes a little bit more pragmatic. It depends on how complex your scripts are, right? So if you've got pretty simple, like select from here, group by, blah, you could automate that if you had all the data sitting in like a centralized code base. But that becomes a lot more tricky, and we actually have not gone that route because we want people to have control. Instead, what we've done is we've notified them that there is going to be a change. We notify them when the change is made, and then it's on them to actually apply the changes. And then everything that we can automate, because it's a simple select, move from here to there, we've automated so they don't have to worry about that. Yeah, good question.
Just one more question.
Yeah.
So with the rise in speech-based AI assistants, so in the future, if Netflix gets support of, let's say, Google Home or Siri or Alexa, so how do you think that data is going to, that data flow is going to be integrated with this?
How do we think that
text data?
How do we think the data flow is going to be affected by home systems and speech recognition?
Yeah, I mean, there will be a lot more text data than we are used to right now.
Yes. I don't have a specific answer, but I would imagine that it's just going to be another endpoint for us, and that it will just be writing out to those ingestions. Typically what's happening in those cases is that there's like another service out there on Alexa or Google that is doing that translation, so we probably wouldn't get visibility to that. It would be more of like, this phrase was made, and then here was the content that was shown, and we'd probably log that in the same way we log pretty much everything, but I don't actually know that for sure.
Thanks.
Sure.
Hi, I have a few questions, but I'll try to put it in one. I missed the first part of your presentation where you were drawing the architecture and you're showing us how data reaches the Tableau dashboard. You mentioned later on that you're using Tableau data extracts and you're building extracts and feeding the dashboard at a certain time. My question is, do you have live connections as the data is flowing through your ETL process, checking the quality and running analytics for people to actually visualize and see and make a change based on what they see? Really live connection to the data sets and running analytics on top of that using Tableau. Or are you guys using Tableau data extracts? I mean, this is really Tableau focused.
I'm going to actually defer this to my colleague Jason Flittner over here, who works more with the Tableau stuff.
Hello. Yeah. I think what you're getting at, you're talking about the data itself on the quality of the data. Are we visualizing that in Tableau using live connection?
The data itself, not the
Yeah.
metadata, how many nulls you got, and all the performance metrics that she showed, but
Sure.
Really looking at the quality of the data and something for a product owner to make a decision on, hey, how do I look as the process is going on using live connections? You're talking about a lot of data, and how do you stream all of that lot of data onto the live connection and not affect your Tableau dashboard's performance, because you really have to go back and look through terabytes of data to be able to get
Sure.
that visualizations together.
Yeah, what I would say there is, the data around the quality checks that are happening is surfaced, not so much via a Tableau live connection today, but where I think there's real opportunity with this data is actually having some sort of aspect of your dashboard that surfaces that information. So in a more kind of easy to understand way, having just an indicator on your dashboard, hey, this dashboard has some stale data, it's being worked on. That's probably a more realistic, thing that we would do, is kind of surface that on the dashboard, rather than, the business user, maybe they won't have as much context to understand the complexity of why the data quality, is not good. So I could see surfacing that kind of like high-level data point in a dashboard.
Okay. I think it's a long line, but perhaps we
Yeah,
can
why don't you
touch base
swing up?
later on.
Yeah.
We can dig in more.
And,
Sure.
and we'll
Thank
stick
you.
around too, guys, so if you don't have a chance to ask your question.
Yeah, appreciate it. Thanks.
Hi, how are you? Quick question. How do you attribute viewing to the recommendation engine versus anything that you can't measure off like off-platform, like so your traditional ads, word of mouth, like someone could have told me about Luke Cage, and then it got recommended to me. So then I watched it, but my first discovery moment was really kind of the word of mouth of my friend.
That's a great question. How do we attribute a view from like a search engine versus a recommendation? And the answer is, I don't know. I'm an engineer, so I don't actually have that insight, but that's a good question.
Okay, thank you.
Sorry.
Hello, my question is about the data validation step. You were saying that you take a normal distribution and you say, look, if we're uploading normally 80 to 100 million rows, and so we kind of find this, and this is what we think we should be able to see. There are obviously lots of events that will cause things to be outside of that normal bounds. So on the, just as a catastrophic event, say the power outage that hit in 2004 that shut down the eastern seaboard, I'm going to go out on a limb and say viewership dropped well outside of your normal distribution if that happened today. So my question is when you're doing this and you're saying this data is not good, and you've set up this automated process that's alerting you to that, how do you then interact to say, well, actually, no, there's a reason for this, or we've looked at it and we actually think this is a good data packet, and then push it back through?
Great question. So to reiterate, it would be when there is a data quality issue or when we find that there's exceptions, how do we communicate and notify that really wasn't a problem, or it really was an issue outside of this that we want our job to continue? Is that right?
Yeah.
So the first thing is I really glossed over that whole piece a lot. So normal distribution is one of the things that we can do. We also do like Poisson distributions. We use anomaly detection. So there's other more sophisticated ways we can do to ensure that there's not problems. When we do find that there are major problems, we're working on right now a alerting service that will allow people to communicate, here's this issue, I'm going to acknowledge the issue, I'm going to annotate what the problem was, and then I'm going to let my ETL move on. So we're working on that right now, but at the moment it would just be a matter of going off and like manually releasing the job to continue to move on to the next step.
Does that power sit in one person or a small group of people that sit down and say, yes, we think this is good, we've discussed this really quickly in a 30-minute session, we think the ETL can continue, or is it not that critical for you guys to be that fast? Or how does that decision actually get made?
I'm going to defer again to my colleague.
Yeah, no worries. So I'd say it comes down to the data point and the team that owns that data. It's not really a centralized decision per se. It would oftentimes, the most relevant team or person would get alerted. Usually it's not just one individual, usually it's a team. And they would dig in, see if there is actually a data issue. If there is, they would fix that. If not, they would release things and hopefully improve the audit so that that same type of anomaly doesn't trip the audit again.
Time frame for those types of decisions?
Again, it can depend on the data set. There are some data sets that you want to have up and running 24/7, and then there are other data sets that run once a day or once a week. So it varies, but I would say that oftentimes that kind of like 24-hour turnaround is a pretty normal kind of timeline.
Cool. Thank you so much.
Sure.
Hi. Question about the statistics that you capture. How did you determine what metadata to capture for your data? And part two, if you find there's a new feature that you want to capture, do you ever have to go back through your historical data and collect that?
Good question. So how do we collect the statistics, and then how do we support evolution of those statistics and backfill if necessary? To answer your question, that statistic is collected. It's collected as part of the storage driver. So whenever data is written, we are collecting that information every time it's written from like Spark or Pig, and we have the ability. The whole model here is collaboration. So people are welcome to create a brand new statistic. We just had this happen recently, and that statistic, in this case, it was looking at approximate cardinality. And so that's something that not everybody would want to turn on, and so we can flag it and say, okay, explicitly disable this by default and explicitly enable this for this one data set so people have that control where it's appropriate. And then we don't really worry about backfilling of the statistics. We have logic that says, okay, if we don't have enough data for this normal distribution, perhaps we should be using some other detection method in the interim. And once we do, then we'll switch over to a normal distribution. Or we'll just simply invalidate that audit until we have enough data for the new statistic. But we wouldn't necessarily go back because that'd be too expensive for us to do.
That mean you have never done it, or just not?
We've
Never done the backfill, or is just not common?
We have never done the backfill because it literally is part of like the storage function, and we would have to either create something brand new. Basically, you'd have to go interrogate that data, and for us, that's very, very expensive. So we want to touch the data as little as we can, which is why we try to collect it whenever the data is being written. Not that we couldn't come up with a solution if we needed to, but we've never had a case where we really needed to.
Hi. My question is regarding Tableau connectivity to interactive queries. Just to be specific, like not to calculate any complex calculation in databases. It's so tedious. Like you want to calculate a standard deviation z-score for around last 2 years based on the dynamic parameterization. You can't do it in databases so easily. So writing in a Python code or creating a web services on top is so much easier. But Tableau lacks a good way of connectivity to the web APIs as live interactivity. I mean, do you guys try to, have you came across these issues, or are there any best implementation models from your side?
I'm going to defer.
I'm sorry, can you repeat the question again?
Actually, I got it. I think I can answer. Sorry. When it comes to the live connections that we make use of, I would say for Tableau, we have primarily used Tableau data extracts in the past. So for cases like that where we need to go out and pull in data from an external service and kind of make that available, we would usually bring it into our data warehouse and materialize that into a table and then pull it into Tableau. For something more like what you're talking about, where you have to go out and hit an external API, we actually use some custom visualization solutions where we do those types of things.
Another Netflix person, sorry, just to add on to that. I think actually the feature that they demoed this morning, the extensions API, is sort of an interesting idea. Like now that that's available, because we've built this as an API-driven service, potentially we could hook into the alert and pull through the extension and place an annotation that says this data that's building this dashboard is suspect at the moment. So there's some enhancements that maybe we can look to bring in that notification based on the alerting that's running in the ETL process.
Yeah, that's kind of an out of the box, but the whole world is now looking into two evolution of the web services where Amazon is promoting as a primary data source for everything, capturing your enterprise data layer as a service based. And a lot of BI tools are not good enough to talk to these APIs. So do you think of any intermediate solutions like that could get to that connectivity, or we should look at it as a separate use case and go as an extension APIs?
Real quick, I'm going to pause. There's a really bad echo, so what I'm going to do instead is invite you guys all up to the front if you have questions, and there's several of us, so you'll get your question answered faster, but just the Netflix group is over here, and if you don't have time to stay and get your question answered, again, feel free to reach out to any of us during the conference. Thanks for coming.
Thank you.